Welcome back, Super Friends. Today we are going to be modeling volume. What that means is that we're going to see some volumes, but in a 3D model, and we have to figure out exactly what that total volume will be. So you'll need your math notebook or folder, pencil to write with, and don't forget that super brain of yours. Stay tuned for the video. All right, Super Friends, today we are going to model volume. What that means is just we're going to be paying more attention to shapes and figures and finding the volume for it. So we're just using models to find volume, just like we do with any other things. We used models to multiply, to divide, to deal with fractions, to deal with decimals. So now we're going to deal with models for volume. So the first example, obviously we need to go ahead and have this drawn and written down on our notes so that we can use it in the future to answer any questions. So feel free to pause the video as you need to. So example 1 says, one row of a figure is shown. What would the volume be if it contained 5 rows? So let's look at the figure. Right now it's showing us this little model, and that's telling us that each one of these cubes has a height, so from top to bottom, of 1 inch, has a length from side to side is 1 inch, and then has a width from front to back is 1 inch. So one thing I wanted to know is that there's a volume equation that is length times width times height. Length is left to right. So we're going to write all these things. Length is left to right. Width is front to back. And then height is top to bottom. Okay, so this all basically means that however we're looking at a figure, to get the number for the length, we have to look at the lines from the left to the right. To get the width, we have to look at the lines from the front to the back of the figure. And then to get the height, we have to look at the lines from the bottom to the top, or the top to the bottom. So that's how we figure out our volume numbers so that we can multiply them out and then get our actual volume. So looking at this one, this figure from left to right, how many cubes do we see? 1, 2, 3, 4, 5, 6. So this is a 6, and that is our left to right is our length. So L equals 6. Let me change this so we could see it. L equals 6 here. Then I'll change the color up. Let's do the length. Let's do the width. So from the front to the back, so from here to there, what's going to be our width? So we see 1, 2, 3, 4, 4 cubes. Okay, so far we have that. And then our height, remember our height is from the bottom line to the top line. So that's our height. And what is that going to give us? It just looks like 1 cube, right? So that's just 1. All right, let's go ahead and set this up. So I have a volume that equals length times width times height. And then we're going to plug in our numbers for each thing. So my length is 6. My width is 4. And then my height is 1. All right, cool. Let's get that volume. Okay, so let's first start. Remember, PEMDAS says you have to start from left to right when it comes to our multiplication. So 6 times 4 is 24 times 1. What does that give us? 24. Okay, so now we have that. Is that going to be our final answer? No, because it says, what if this figure contained 5 rows? So remember, 5 rows just mean that we have the same picture, but 5 times. So what I would do, because we said 5 times, we would just times our current volume and times it by 5. So now we have, it's like saying that our height is 5 instead of 1. That's what that's saying. So instead of the height just being 1, we would make more heights so that it's 5, because they said 5 times. So 1, 2, 3, 4, 5. That's what that would be. Okay, so now I always like to do a little area model to get my multiplication going, only because it makes my brain happy. I bring down that 0, and then I do 2 times 5 is 10. Put a 10 in front. Then I have 5 times 4, that's 20. If I add this together, it's 120. So our volume here, our total volume, is 120, what is it, inches cubed. We put inches cubed at the end because we did inches times inches times inches. And that means it would be inches cubed, or cubic inches. So that's how we get this first problem. It's 120 because we got the volume of what we already saw, but we had to multiply it by 5 because we wanted it to be a row of 5. So that's why we did that. Let's go to the second example. All right, Victoria partially filled a box with cubes. How many more cubes does Victoria need to completely fill the box? All right, so this one, what I would do is kind of a two-step problem. I would find the volume for what we see already, and then subtract the volume of what we don't see. And then that would help us figure it out. Or we could even just get the volume of what we don't see and then go from there. So let's first go with our second part. We need to figure out what is the volume for this area here. What is this volume? Thankfully, they have everything else filled in, so then we can go ahead and figure this out. So let's get the length from left to right. So from left to right, how many cubes do I see here? 1, 2, 3, right? So that is 3. Length equals 3. Let's look at the width. So from here to here, how many cubes do I see? 1, 2, 3, 4. So height equal, or not height, width. Width equals 4. And then lastly, let's do our height. Our height is going to go from top to bottom. So here, and then how many cubes do I see there? 1, 2, 3. So our height is 3 again. So now this is just telling us what is needed. And the reason why I wanted to look at what was needed and not what we could fully fill in all of this is because what is needed is just easily what our answer is. They're asking how many more cubes does Victoria need to add to completely fill the box? And that's just all of this area right here. We need to fill in all of this. How do we fill that in? And the way that we fill that in is by getting the volume of what we found here. So let's go ahead and start. Volume equals length times width times height. All right, let's fill it in. Our length is 3. Our width is 4. Our height is 3. And then we solve. Again, start from left to right. 4 times 3 is 12. 12 times 3 is what? Who knows our 12's facts? All right, 36, correct. So it would be 36. And did it say how many inches or anything like that? No. So we would just say 36 cubes because they only mentioned cubes. 36 cubes more. And that's just finding the volume of that little figure. Okay, that one was pretty simple. Let's go ahead to the last example. The only thing I want us to remember is that the thing that's going to be consistent and recur often or happen many, many times in every problem is that you're finding the volume, which is length times width times height, no matter what. There's going to be cases where we have to find the volume twice and then add it together, or we have to find the volume twice and then subtract it. So either way, this is what we're trying to do, is do that length times width times height. Let's do the last one. All right, Rachel is using 1-inch cubes. Okay, cool. They gave us that a little example, so it's going to be cubic inches. So inches cubed is what our answer is going to be. To find the volume of the following box. What is the volume of this box? Okay, that was easy. So we just need to figure out what's our length, what's our width, and then what's our height so that we can multiply it together. So let's go ahead and start. Let's start with the width, because I want to show you what's going on here. So the width from the front to the back, what is that going to give us? So what we need to do is look at what boxes we see on the sides. So I see 1 here, then I see 2, 3, 4, 5. 5. Normally we would just say it was 4, right? 1, 2, 3, 4, but you cannot forget this last row. So it's our 5th row. Okay, let's do the height. So from the bottom to the top, how many cubes do I see? Again, we start here. 1, because that's our bottom cube. 2, 3, 4, 5, 6, 7. 7 cubes here. So our height equals 7. And then lastly, we're going to do left to right, which is our length. And we start here because this is our first one. 1, 2, 3, 4. Normally it would have been 1, 2, 3, but this last one in front is our 4th one. So length is 4. So let's go ahead and start plugging them in. 4 times 5 times 7. And then what do we get? Again, left to right. 4 times 5 is what? 20 times 7 now. We bring down our times, bring down our 7. Okay, 20 times 7. How many times 7 times 0 equals what? 0. And then 2 times 7 equals what? 14. I'm going to put a 14 in front. So our answer is going to be a volume of 140 cubic inches, or 140 inches cubed. That's how we say. You can say cubic inches, or you say inches cubed. That's just how you speak it. You don't have to worry about writing it that way, because most of our stuff is multiple choice. But when you're speaking it, I want you to be able to use the correct language. And you say cubic inches or inches cubed. All right, use these notes to help you solve your problems for today.